Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 5.3.1. Number 99 says, Mr. Knowling's garden has a length that is 7 feet more than twice the width. Draw a diagram to represent the situation. Label each side of the garden and then write an expression for the perimeter. Okay, so in this situation, this is kind of like getting us ready for our problem-solving 5D process that we're going to be working on in the next lesson. But just being able to read through a problem and then in some situations draw some kind of a picture diagram to help represent what the problem is telling us, it can be very, very helpful for understanding, a particular problem. So I draw the diagram. It's got to be a rectangle, right? Because it's a garden. It's got length and a width, and we're trying to find the perimeter. So it says 7 feet more than twice the width. So if this is the width, then this would be 7 more than twice. Now, I don't really know what the width is supposed to be, so I'm just kind of guessing that's just a random length here for the 7. But since I made the width here 4 units, I decided to make this 4, so you got a total of 8 of them here, right? Because it's twice the width here, twice the width there, and so on and so forth. So the expression for perimeter would be 6w plus 14. That quantity is going to be the number of feet. So, you could go through and say, well, what if the width was 4 feet? This would be 8 and 7 makes 15. This would be 15, and this would be 4. So the total would have to be 38, right? So let's take 6 plus 4, or 6 times 4 would be 24, and 24 plus 14 is going to be 28. So just like what we were working with when we were working with tile figures, the same approach can work in problem solving as well. All right, so the following number lines are missing some numbers. Use the information provided to complete number lines. All right, so basically, what we want to do is we want to say, all right, you're going from here to here, and it's going to take you how many steps? 1, 2, 3 to get there. So how much do you go up going from -12 to 6? Well, it takes you 12 just to get to 0, plus another 6 is 18, and it took you 3 steps to do that, which means that every step must be counting by 6s. So let's see if that works. -8 plus 6 is -12. -12 plus 6 is -6. -6 plus 6 is 0. 0 plus 6 is 6. Yes, that absolutely works as the counting sequence. So we're just going to continue on with that process. Here you're going from -27 to 0. So you're going to increase by 27. And how many steps does it take you to get there? It looks like you go 1, 2, 3 to get there. So we must be counting by 9s. And so there you see your counting sequence, counting by 9s. For this one, you're going from 0 to 700. So you're increasing by 700, and you're doing it in 2 steps. So 700 divided by 2 means you're counting by 350s. So you can see the counting sequence, counting by 350s. And in the last example, you're going from 0 to 33 in 1, 2, 3 steps. So let's take 33 divided by 3, which means that you're counting by 11s. So you can see the counting sequence by 11s works there, okay? So remember, how much does it go up and how many steps does it take to get there? That's going to tell you what your counting sequences are every time on these number lines. All right, Lynn was shopping and found a purse that was marked with a discount of 1/3 off. If the original cost was $80, how much will Lynn pay? Okay, so in this situation, I'm going to create a diagram, and I'm going to break it up into 1/3 sections. This represents 1/3, this represents 1/3, and this represents 1/3. Now, the total cost was 80, right? So if I want to break that 80 into 3 equal parts, let's see what that is. What is 80 divided by 3? I'm going to use the calculator to figure this out. 80 divided by 3 is 26, and we would call that $26.67, basically. $26.67. Okay, now there's a bit of a problem here. First of all, my pen is working very poorly. $26.67. That's a round up, right? If it's not rounded up, then then you're not rounding properly. But this is going to present a little bit of a problem. So if I say that this is $26.67, this is $26.67, and this is $26.67, well, we got a bit of a problem there because all of those adding up, $26.67 times 3 actually takes you $80.01. So let's just do this. Let's call one of these 66 cents, and then the other two will have the 67 cents. That should work just fine. Okay, so now we're going to add these two guys together, and we end up with this as our answer, $53.33. Okay. Okay. Evaluate the expression using the order of operations. All right, so the order of operations is defined by PEMDAS, and remember, you can do one of two things. You can use the traditional PEMDAS method, or you can highlight the terms or circle the terms and solve each individual term. That becomes a little problematic when you get a problem like these, since it's really only one term here, okay? So this is what I'm going to do. I'm going to let you, in fact, actually, I'm going to do two of these. I'm going to do B and D. If you need to see me work out A and C, just give me a ring, let me know, send me an email, and I'll work this out for you. But let's start with B. Can we all agree we do not like all those minus signs? It's horrible. So what I'm going to do is I'm going to do the whole KFC approach, changing all of the subtraction parts to addition. And so eventually what happens is this. The first one just tells us the sign of the numbers. That's -3. But instead of subtracting 3, let's add a -3. And so we're now here. Now we're going to keep that -3 and add another -3. And now we're here. We're going to keep that. Now we're going to add the opposite of -3, which is a +3. So we end up with here 3 -3s being added together is -9. Then at the end, we add a +3, so that ends up giving you -6 for an answer. And then this problem, the whole parentheses, I never really said this originally when we were talking about the parentheses, but really it's parentheses from the inside out. So we've got multiple parentheses happening here. There's a parentheses, but there's nothing to simplify on the inside of that. So we'll leave it how it is. There's a parentheses. We'll leave that on the inside, or there's nothing to solve there. So actually, there are no operations to do inside of parentheses. So that's good. So these two being next to each other means you're multiplying them. So we have to do the order of operations inside the parentheses. So we're going to have to take 2 and add that to -15 inside the parentheses. And on this one, we're going to take 3 and add that to the -12, which is inside the parentheses. So now 2 plus -15 is -13, right? Because you're adding a positive to a negative, which means you're going to actually subtract the numbers and keep the sign of the bigger number. This one is going to be 3 plus -12, which is -9. And remember, when you've got parentheses next to each other, like we've got there, that means you're multiplying those two numbers together. So 13 times 9. This is a 27, carry the 2. That's supposed to be a 7 there. All these pens. Okay, and that's going to be 117. So yeah, and it's a negative times a negative, which gives you a positive answer. So our answer there is 117. Ooh, what do we have here? Complete proportions web. Oh, proportions web. All right, so it says a candy wrapping robot can wrap 434 pieces of candy in 5 minutes. Okay, so that's the situation, right? So what we want to do is we want to identify what is the unit rate. Stop, I don't like that. Let's identify what the unit rate is by taking 434 divided by 5, and there you see the work there. That means that this candy is wrapping candy at a rate of 86.8 pieces of candy per minute. Okay, so that's the unit rate. Then that can be expressed as an equation where you take the number of minutes and multiply it times the unit rate, and that will give you the total number of pieces of candy that have been wrapped, right? So if we took 5 times 86.8, that would tell us 434 pieces were wrapped in 5 minutes. Okay, so you got the two variables and the unit rate. So all of these situations can be expressed in an equation. You can, of course, set this up as a table where you see the unit rate there in the table. We know it's proportional in nature because if you don't spend any time wrapping pieces of candy, there are no pieces of candy that get wrapped. And then, of course, the problem started off with 5 pieces of candy could be wrapped. No, 434 pieces of candy could be wrapped in 5 minutes. And then the last way that you can represent this information is in a graph. So, the unit rate is down here. This is the piece of information given. And of course, you've got the origin 0, 0. So all graphs for proportional situations are always a straight line that pass through 0, 0. Okay, so the 4 representations of proportions: the unit rate, the equation or rule, the table, and the graph. And that is it for our homework. Hooray! All right, let's move on to the next activity.
Hey, feeling good.